Now we are going to find an expression for exchange current density. We all know the reaction rate theory in kinetics. There is an energy barrier between reactants and products when a reaction taking place. Similarly, here also, when a metal goes into solution and for the reverse process, it has to cross over an energy barrier, where here delta G star is the activation energy barrier when the two processes are in equilibrium. First, any of the reaction will start, and when it reaches equilibrium, delta G star be the activation energy barrier. In this reaction, the forward reaction is the reduction and the backward reaction is the oxidation, producing IC and IA current densities respectively. At equilibrium, rate of forward reaction or rate of reduction is equal to rate of oxidation or rate of backward reaction and become R0. Since rate by kinetics, from the same kinetics, rate is the number of moles of ions crossing per unit time per unit area. By Faraday's law, R is equal to I by N, where I is the current density, N is the number of moles of electrons involving in the reaction, and F is the Faraday. Since R oxidation equal to rate of reduction equal to same R0, we can say that IC by NF equal to IA by NF equal to I0 by NF, where I0 is the exchange current density or the current density at equilibrium. If N1 and N2 are the number of atoms per unit area of metal surface IHP and OHP in a Helmholtz plane and at the outer Helmholtz plane respectively, and nu1 and nu2 are the frequencies of vibration of atoms, and F1 and F2 are the fraction of atoms crossing the barrier. The rate of forward reaction and rate of backward reaction can be written like this by the same classical rate theory that you have studied in kinetics. You may have studied the Arrhenius equation. This can be a constant, that is the Arrhenius constant, which involves the same type of parameters. If N1 and N2 can be written as N, that is the same number of atoms are involving. We are assuming that the same number of atoms are involving in the both of the processes. In both processes, the same number of atoms are involving, and their frequency of vibration is fixed as 10 raised to 13 second inverse. And we are also assuming that the complete atoms crossing the energy barrier. So the fraction becomes F1 and F2 equal to 1, equal to F, and same fraction, and it's almost all atoms crossing the barrier. If we are assuming it becomes F and it's equal to 1 since it's a fraction. Then we can have, when RB and RF equal, we can write R0 as N mu F into e raised to minus delta G star by RT equal to the exchange current density by number of N into F. Hence, I0 exchange current density can be expressed by this equation. This is an important equation by which we are going to explain other processes in coming lectures. Thank you very much.